The next technique that we had is code-based evals. And these are the most familiar to people usually. This is just the same as any kind of other evaluation that you might do in a pre-AI world, where you just run code on the outputs of your application. So in the same way as before, you can run these in development or in production, and you can run them on any part of your application because we're tracing the whole application itself or the whole agent itself. So you can run these on different pieces. But because it's code, you have to be able to write the eval in code. So you're limited on the kind of thing that you can evaluate. You can't really write a hallucination eval using a code-based approach. You kind of have to use an LLM because it's a little bit more qualitative / it's a little bit harder to define in pure code. Code-based evals do work great for things like whether responses match regexes, whether the response is JSON parsable, especially if you're working with models that don't have structured output or don't have a way to enforce structured output. It's very helpful to be able to use one of these evaluators. Containing keywords is a big one. This is something we see a lot of enterprises doing. If you make a chatbot and put it on your website, it kind of doesn't matter what the response is, but if the response contains your competitor's name, you probably don't want to say it because it could be good, in which case that's not great for you. It could be bad, in which case the competitor might get mad or something like that. So we see a lot of people who are just filtering out responses that contain certain keywords. And then finally, you could also do comparison to ground truth data. So if you do know what the output should be, then you could do a code-based eval to just do a comparison to that output, either directly or semantically as well. The one that's not on here, that's actually on the example on the right, is checking if generated code is runnable. That's actually a very common one we see too, is if you're generating code, you can actually, after the fact, kind of pull it out of the trace, run it in a closed test environment automatically and see if you get any errors. That's a very common kind of code-based eval that we see. So if you can do something in a code-based eval, you generally should, as opposed to LLM as a judge. Like if you could define the eval that you want to do with code instead of using an LLM, it'll be more accurate. So you generally want to do that. It'll also usually incur less cost as well too. So it's preferable to do something in code if you can, but you usually can't depending on what the technique is. And then the final piece is a little bit of a kind of different kind of category here, which is human annotations. And so the other concept that you can do is you can collect human feedback on the runs of your application. And there's usually two big buckets of this. One is either you or your team or labelers that you've employed or something along those lines can go into the runs of your application, the traces, kind of the logs, and they can label things from there. So they can actually just manually human review the data. And that is worth doing. I think people have an aversion to doing that sometimes because they're thinking, hey, I'm building this automated system. My evaluation processes should be automated as well. But it's very hard to achieve the same understanding of your application if you don't just go into the data yourself and look. So it's always good to do that to some degree as well too. And then the final piece is that you can also gather feedback from your end users. You guys have probably seen this if you ever used a chatbot that has like the thumbs up, thumbs down. Was this a good response? That is usually being recorded, associated with traces, and going back from there. And so you can pull in that user feedback. It could either be the thumbs up, thumbs down, or something beyond there as well too. Okay, so those are kind of the main areas that we usually look at for evaluation. So some of the main kinds of evals and techniques that we'll use for evaluation. So now we're going to talk about how we apply those. We'll go through a little bit of a demo showing how we apply those different techniques. We'll use this travel agent example. Something I like showing this slide because this is something that I see from a lot of customers where they're wanting to do kind of voice-driven agents. They'll have natural responses, real-time responses, all these kinds of different things. I like to show this because I just like to kind of highlight that it's as important as those advanced features are. Just having a good response is almost more important as the base. So it's always good to start with those pieces as well. I'm going to jump into a demo here. So for those who joined last time, I used a tool called Phoenix, which is one of the tools that Arize makes to show some of the process of tracing an agent. So I'm going to be here using Arize AX, which is kind of Phoenix's big brother. You can still sign up for this for free on our site on arize.com. You can sign up and make an account if you want to go through and follow along. Everything I'm going to show you could also be done in the open source tool that we looked at last week, Phoenix. However, it's more in the UI in this tool and makes it a little bit more streamlined to show for the demo purposes. So just know I'm going to show how this process works with these tools. However, you could use the same process, the same eval approaches if you were using Arize AX, if you're using Phoenix, or if you're using a completely different platform. You could code it yourself. You can use all those same techniques that we just talked about, not using this platform as well too. In this example, we have our example travel agent, and I've preset a whole list of traces of that agent so we can see how that agent is performing. And I'll just click into one of these for now. I've kind of mocked this up. And so all it's really doing is saying, okay, we're going to take an input from a user that's asking, can you fly me a flight to a destination with a vibrant music scene and beautiful nature? And then we are going to our router. And our router here has a set of different functions that it can call. So the router can call a search flights function, and we can see all the parameters that are associated with that as well here too. It has the search hotels. It has one for get destination info, track reservation, search activities, and apply a discount. And so if you think back to some of the evaluation stuff we talked about earlier, there's really two jobs the router's doing. And so I mentioned that one of those jobs is choosing which of these different functions or skills to call, which of these paths to go down. The second job is to actually get all of these values right. So if it's going to choose the right thing, it's got to know what's the departure city, what's the destination city, what's the departure date, all those different pieces. So it has to know what those are. And you can see some of these are required and some of them are not. And so it has to actually get that job right as well. And so you can see in this case, our router is taking that input, and then it is getting destination info. Okay, so it's making a decision to get info for Austin, Texas, and it's going to have attractions for the info type that it needs. And then we can actually see it's going to call that particular tool. And I've just sort of done dummy functions for these tools. They're just going to give us back kind of a placeholder output there. But we can, in this example, we're going to be evaluating the router specifically. So that'll be our main thing that we want to look at. And you'll see that one thing here is we've run one eval on that. And so if I click into that eval, this is now an LLM-as-a-Judge eval that we've run automatically on this run. And I'll show you how we've added this particular thing. And so in this case, it's saying the tool calling was incorrect. And one of the nice things about LLM-as-a-Judge is that you can actually have an explanation generated as well. So you can actually read through the explanation. You can see, in this case, it's about finding a flight to a destination with that vibrant music scene and beautiful nature. And then our agent in this case chose to call the get destination info function, not the search flight function here. So in this case, it got it wrong. It didn't actually choose the right thing. So we can see that that gave us our incorrect label there. And so we could click into other runs as we go through, and we could see all the different decisions that were made. We could review our eval results. And this is kind of when I talked about looking at the data. This is something that is generally good to do. You do want to kind of go in and look at some of the data and see where your application is making mistakes. However, this is not necessarily going to be the most scalable thing. So we'll talk a little bit more about how you can do it at a more scalable level in just a second. So that's kind of what the eval looks like.